Sometimes when you're given a quadratic equation, you can't factor it, like it's unfactorable, or the numbers are so large that it's hard for you to factor. And when that happens, you can use the quadratic formula to solve a quadratic equation. So a quadratic formula actually will help you solve any quadratic equation as long as it's in the proper form. And by that I mean you need to have your equation in standard form and one side has to be equal to 0. And the quadratic formula looks like this. So A represents the coefficient of x squared, B represents the coefficient of x, and C represents the constant. The quadratic formula is x equals negative b, which means whatever the coefficient b is, take the opposite sign, plus or minus, that's what gives you the two options, the square root of the b value squared minus 4 times a times c, all over double A. So let's try this out. Looking at x squared plus 8x minus 3, you might see it as a simple trinomial and try to think of what two numbers multiply to negative 3 and add up to 8. And you will not find any combination. So we go to the quadratic formula. Here our a value is 1, b is positive 8, and c is negative 3. So with the quadratic formula, you would start x equals negative b, so negative 8, plus or minus the square root of your b value squared. Always put the b value in brackets, and whatever that value is, when you square it, it will become positive. That is super important. Make a note of that because people mess that up sometimes. So b squared minus 4 times your a value times your c value. And then it is all over. So that dividing is at the very end, all over 2 times 1. In the next step, what you should simplify is in one step, simplify what's under the square root and simplify your denominator. The denominator will just be 2. And then under the square root, what you'd be doing here is 8 squared is 64. And then negative 4 times 1 times negative 3 is positive 12 because of the two negatives. So 64 plus 12 is going to be 76. And you can do that either in your head or you can do it in your calculator. But here it is. And notice that the 64 was positive. And it would always be positive even if it had been negative 8 squared. And now this would be the exact solution. So one of the exact solutions would be negative 8 plus the square root of 76 all over 2. And the other would be negative 8 minus the square root of 76 all over 2. Those are exact. If I wanted the rounded answer, you would go to your calculator and you'd plug these in. And when you plug them in, you would do negative 8 plus the square root of 76. And you could press enter here and then divide it by 2. Or make sure you put the negative 8 plus root 76 in brackets, then the division by 2. So I want you to pause the video and try that in your calculator right now to make sure you know how to use your calculator to get the correct answer. So pause it and then come back. So hopefully on your calculator you see 0.36. So that's what I've rounded it to. And then again, pause the video here and do the same thing for the other one, except this time it's going to be negative 8 minus the square root of 76 in brackets divided by 2. And you need the brackets there because you want the divided by 2 to happen at the very end. So go ahead and pause and then come back. So hopefully you got negative 8.36. And those would be your two x-intercepts or solutions. Okay, let's try some more. So here we have negative 5x squared plus 18x plus 1. Our a value here is negative 5, b is 18, and c is 1. So I want you to pause the video, put these values into your quadratic formula, try to simplify it, and try to get those rounded answers and then come back to check your work. So when you plug it in, we should have negative 18 for negative b, plus or minus 18 squared minus 4 times negative 5 times 1, all over 2 times negative 5. When you simplify it, hopefully under the square root, you have 344 from 324 plus the 20, and then that's going to be all over negative 10. So the exact solutions would be negative 18 plus the square root of 344 over negative 10, or negative 18 minus 344 over negative 10. And that's because of that plus minus. When you plug this into your calculator, make sure you're using the approximate squiggly signs, and you should have approximately negative 0.05 as one solution and approximately 3.05 for the other. If you made a mistake, check to see where that mistake was made, either maybe in the setup or when you are simplifying, or just how you used your calculator. All right, let's try our next one. And in the next one, I personally wouldn't use quadratic formula here. I would just do a common factor. But in case you blank and you really want to use quadratic formula, I want to make sure we know how to do it. So we can clearly see that a is negative 5 and b is positive 30, but there's no constant there, which means c is 0, because this can be written as negative 5x squared plus 30x plus 0 equals 0. And now let's go ahead and put this into our quadratic formula. So negative b, negative 30, plus or minus the square root of b squared, so 30 squared, minus 4 times a times c. Now notice you're multiplying that last part by 0, which means this part here, this negative 4 times negative 5 times 0, is actually going to become 0. And then all over 2 times negative 5 for 2a. And then when we clean it up, we're going to have the square root of 900 all over negative 10. Now, if you look at all the other scenarios, when you try to square root 344 or square root 76, you get a run-on decimal. But this square root of 900 is actually an integer. You can actually square root it. So if you notice you get a perfect square under the square root, then don't branch off right away. Just turn that square root of 900 into just 30. And now I will have negative 30 plus 30 over negative 10, or negative 30 minus 30 over negative 10. And here you don't even need a calculator. You can just simplify it on your own. So negative 30 plus 30 is 0. 0 divided by anything is 0. And then negative 30 minus 30 is negative 60, divided by the negative 10 is positive 6. So your two x-intercepts here are 0 and 6, which you could have gotten by factoring as well. But now you have two options. All right, let's go to our next one. Now here we have a little problem in that we have equals 7 at the end. So that is not good. You cannot start your quadratic formula here. You cannot say that c is equal to 7 because it is not. We have to bring the 7 over first. We need to get this in standard form, and now notice that our 7 is negative. Now this is ready to go. A is negative 3. B, if you don't see a coefficient there, is just 1, so positive 1. And C is negative 7. Now, I want you to go ahead and put this into your quadratic formula. So pause the video. You might encounter a problem. And if you encounter a problem under your square root, come back to the video so that you can see why you encounter this problem. So you might have noticed when you subbed everything into your quadratic formula, when you simplify what's under the square root, you end up 1. And then because I have 3 negatives here, that would be negative 84. When you do 1 minus 84, you get negative 83. If you try to put that into your calculator, you're going to get an error because you can't square root a negative. If that happens, it doesn't mean you've done something wrong. It just means there is no real solution. And the reason is because there are no intercepts. Therefore, no real solutions. So the no x-intercepts part is just the visual part. Visually on the parabola, you won't see that it passes through the x-axis. So if you get a negative value under the square root, double check your work to make sure you didn't make a silly mistake, but otherwise it means that there is no solution there. Now, for the next one, again, I have a problem in that there's a 6x on the right side. I have to bring it over, and when I bring it over, I have to be careful and make sure that I put it after the x squared, because I know that I should have x squared, x, then constant. So now I see that my a value is 1, b is -6, and c is 9. So let's go ahead and put this into our quadratic formula. So x equals -b. So b is already negative, so when I put the double negative, it will be +6. So I'm just switching the sign. And then plus or minus the square root of -6 all squared minus 4 times 1 times 9 all over 2 times 1. Now when I clean this up, I want to take note, I am going to go a bit longer here. -6 squared is going to be +36, not -36. And then -4 times 1 times 9, -36, all over 2. Now when you do 36 minus 36, you get 0. And the square root of 0 is 0. And if I try to do 6 plus 0 or 6 minus 0, it's the exact same thing. So in this scenario, you're only going to have one distinct or different solution because of that 0 under the square root. And the only solution here is 6 over 2, which is 3. Now in these last two scenarios, it was what happened under the square root that dictated how many solutions you have. And under the square root is that b squared minus 4ac. This actually has a special name, and it is the discriminant. This is something you'll see more in grade 11, but this part that is under the square root tells us how many possible real and distinct solutions we have. Notice in the second last example, when we had a negative number for that b squared minus 4ac, we had 0 or no real solutions. In the last example, the number under the square root, that b squared minus 4ac, was 0. And that gave us one real distinct solution. And when the number was positive, like the other examples, we had two real solutions. So don't get scared if the part under the square root, that b squared minus 4ac, is negative. That just means 0 solutions. Or if it's 0, you'll only get one distinct solution. So keep that in mind. But again, that's more something you'll see in grade 11. So once again, the quadratic formula is a tool that you can now use for any quadratic equation when you're solving for those zeros or those x-intercepts. And it helps you find the solution without actually factoring, because sometimes an equation isn't factorable, or it's just really hard to factor because the numbers are too large, or you just don't feel like factoring.